Hi everyone, this is Jared, AC7WH, Backyard Ham Radio. Today I would like to show you some things that I've learned with my RigExpert AA-35 Zoom antenna analyzer. I also want to mention why I chose this model rather than the RigExpert MATCH analyzer. In short, there were three things that persuaded me that this was definitely the better option for me personally compared to the RigExpert MATCH. So number one, this RigExpert has user replaceable batteries. You can use nickel metal hydride or you can use alkaline batteries, and you just open up this battery door, you unlock it with this slider here, and then you just replace the AA batteries. It's really easy to do. Secondly, well, before I go too far, I didn't finish telling you why that's a big deal. Let's not forget that. So, yeah, big deal, sure, that this has AA batteries you can use, but in comparison to the RigExpert MATCH, it has a lithium-ion recommended to not be user serviceable battery. Now, the instructions from RigExpert say that you should bring it or send it to a service center rather than replacing it as a user. Now, I understand lithium-ion batteries can last for a very long time, so perhaps with the right charging and so forth, you may be able to keep the same battery in a RigExpert for many years, but the fact that it is recommended not to be user replaceable, and whenever you do replace it, it could be a unique battery that you can't find when you need it, that to me is a big drawback. So if you want rechargeable batteries, use some rechargeable nickel metal hydride AA size batteries with a RigExpert like this or one of the other RigExpert designs. So that's number one. Number two is, you'll see here we've got the typical type supposed UHF connector. I realize these are not necessarily the best for UHF, but the UHF connector, the PL259 SO239 type connector, as opposed to the N connector that the match device uses, because it is capable of going well into the UHF range. So because of that, it makes sense. But since all of my transmitting is either in the HF band or occasionally in the medium frequency band with 160 meter band or the VHF range with the 6 meter band, other than those special circumstances, I'm entirely using the HF band with my equipment right now, and so this type of connection goes right with my coax. So the third item for me, even though I realize, yes, I could get an adapter to go from this type of connector to an N connector or vice versa, I am happy that this connector is what came with my RigExpert. Okay, so the third item is, I am very glad that this analyzer is essentially an all-in-one unit, whereas the match device, it's essentially software defined and you have to get a license to be able to use higher frequencies. Yes, it does come with a little bit wider frequency range than the AA-35 Zoom does, where this goes up to 35 megahertz. The match, from what I recall, goes up to 70 megahertz just out of the box without any extra licenses. However, especially with so many uncertain times right now, I would rather have something that is ready to go. It is something that I am owning, not just licensing or whatever. I want to be able to have everything self-contained in one unit. So the batteries, the connector, and the fact that this is an all-in-one unit without having to get extra licenses to expand privileges and use that extra software that way, it just doesn't make sense to me. I get it, some ham radio operators and other users will appreciate exactly what that match device does, but I like this more classic design. Okay, let's take a look at what I can do with it and some of the other information here related to my antenna and why I got this analyzer. Okay, so you'll see here I'm in the main menu, and I'm going to go ahead and start out with number 4 there, which is the SWR chart. And I'm going to go to number 9 to load. And I want to load an example here that came programmed into the memory slot 00. So I'm going to go ahead and hit OK with the check mark there. All right, in this particular example, it shows that the minimum SWR is 1.17 at 14,250 kilohertz, or 14.250 megahertz. And you see this nice dip. Okay, so let's go ahead and compare that with the next chart. So I'm going to cancel out of that view with the cancel button. Let's look at the R and X chart. I'll explain what that is here. Okay, so the resonance is at 15.165, so slightly higher frequency than what the lowest SWR is, because the resonance is based off of when the inductance and the capacitance are balancing each other out, so that there is essentially just pure resistance or impedance measured as resistance in ohms. And so that is slightly different than what the lowest SWR is, keeping in mind that right now I have this set up as if it is using 50 ohm coax. Now you can set this, for example, to 100 ohm coax if you wanted to, or 75 ohm coax. It gives you a range of choices. Other models have even more choices, like for ladder line and so forth. But with this, you'll see, as is often spoken about, that the resonance is not exactly at where the lowest SWR is because of the natural impedance of a resonant antenna. It can be different than 50 ohms of impedance. So anyhow, there's lots of other videos out there on that topic. Feel free to dive in more deeply. I'm not going to cover that in depth right now, but I just want to show you that this is what is displayed on the RigExpert. And so the yellow R line that you see kind of waves up through here near the top, that is the resistance, technically impedance in ohms. And the blue line, if it is in the negative, from what I recall, that mentions in the instruction manual that it is capacitance, and if it's in the positive, then it's inductance, if I'm not mistaken. So that's why you see a negative 25 up to a positive 25. Okay, so you can see how these different figures are changing. And by the way, the vertical blue bars, so like this one right here and this thinner one here, those represent ham radio bands. Okay, let's go ahead and cancel out of that. I don't want this to be too detailed, but that is an example of the antenna that is loaded within the memory as an example. So let's go ahead and take a look. Again, very briefly, that's the one that comes loaded. Okay, so now I'm going to try to load one that I did. I ran a quick test, but by the way, that example was a 20-meter delta loop. Here is my previous antenna length, where I had the antenna at about 40 feet or so for a sloping vertical with a 40-foot horizontal radial and then some shorter radials. And so I called this my long antenna because I shortened it shortly thereafter. So let's go ahead and see what this loads up as. So you can see here the minimum SWR is 2.7 at 16.860 megahertz or 16,860 kilohertz. So that's not really helping me on the ham radio bands except for using my antenna tuner, which I normally use anyhow. But you'll see how it never really dips low in the SWR on any band. Again, each of these vertical blue lines like this one are the ham radio bands. So this would be like the 10-meter band here. So with that, thank goodness I have the antenna tuner. However, let's see what our reactances are looking like. Why are we not seeing a nice dip anywhere in here? I'm going to the resistance reactance chart. So you'll see that the resonance is at 17.626 megahertz. So that's great, but there's a lot of reactance all over the place here. Now that's not the end of the world, but it's as if there's just too much that is affecting this antenna. More on that in a moment. I'm going to go ahead and go back to the SWR chart. Notice the minimum SWR is at 16,860. I'm going to go ahead and load the antenna results. When I had shortened my antenna, I took approximately 2 meters off the length of both the vertical antenna and the longest radial, so that now each of those are about 10 meters or around 33 feet. And now, yes, sure enough, as we would expect, the minimum SWR is higher. It's at 19.376 megahertz. And you can see there are some various dips here, kind of in between the ham radio bands. And thankfully, my antenna tuner will tune that. But nothing has a nice low dip down into, for example, a 1.5 to 1, let alone a 1 to 1 SWR, where I would not need my antenna tuner. Let's look at one more bit of data and then I'll explain my theory as to why that is. I'm going to look at the inductance chart for the resistance or impedance and the reactance, to be more exact. Okay, so it shows the resonance at 16,745. I am seeing some loops there of the resistance and impedance in the yellow, and then you'll see the light blue up and down and up and down. You can tell because it flatlines at the top and the bottom. It's actually beyond the scale of this particular reading, so beyond negative 25 and beyond positive 25 for the reactance there. But my theory as to why I am seeing this is because in my yard there is such a small amount of space around the wiring for the deck, as well as for the metal on the shed and metal for the basically the rail for the deck, as well as not far away is the house itself before you get to the end of the yard, and I would have my antenna at the end of the yard. So I recommend checking out my previous videos so that you can see what my antenna setup looks like. But basically, it is such a tight space within a very small fraction of certain wavelengths, depending on the frequency I'm using, that it makes it difficult to fully tune up without an antenna tuner. And even with the antenna tuner, there are certain limitations. So with both the long antenna and the short antenna, I was not able to tune up on 10 meters, and part of that is because it is such a long wire. But this is an interesting situation, and I'm looking forward to further testing. The good news is it doesn't seem to be hindering me from being able to make some contacts. And again, thank goodness I have that antenna tuner, because otherwise I just cannot get a low SWR, at least with this type of setup. If I got a high tower or something like that, perhaps I could. But be sure to check out my previous videos. I'm going to go ahead and say 73. Thank you so much for watching.